Hello children, welcome to AIMS India's online classes. In today's video, from physics subject, motion topic we are going to discuss. So, if you observe this video children, so all the objects are falling onto the earth. So, all the objects are falling onto the earth. From top, they are all falling onto the earth. What may be the reason? Because here the earth will be having a nature called gravity property. It will be having a property called gravity, or it will show gravitational force which tries to attract all the objects. Means because of force, motion is created in the objects. Because of force, some kind of motion is created in the objects. So actually motion is caused by force. So when motion is caused because of force, what changes we will observe? Because of force? If it is already in a rest position, because of force, it will move. The body, it will move. Already if it is in rest position, because of force, it will move. So, or if you take the example of cricket game, so the ball coming from the batsman after hitting, so we can catch it. We can catch it with our hands, so it will stop. Means if it is already in motion, like cricket ball, we can stop it. Means we can make it come under rest. Or if you take the example of sponge, so what you can do? You can squeeze it and you can change the shape. So like this, whenever we apply force on a body, it may create motion, or it may stop motion, or it may change the shape. Like that, so many effects may happen. In that, motion also one kind of effect caused by the force. So the branch of physics which deals with effect of force on objects, particularly regarding motion, is called mechanics. So this branch of mechanics again classified into two categories. One is statics, another one is dynamics. So here statics means, so branch of physics which deals with the objects at rest under the action of forces. Suppose you are having a block, you are having a big block here. You are trying to apply force. And you are trying to move it forward. But still it is not moving. It is under rest only. It is under rest position only. So you are applying force, but the block is not moving. It is under rest position. So in that condition, studying about this body which is under rest under the action of force is called statics. So the branch of mechanics which deals with objects which are under rest under the action of force, it is called statics. Suppose if the block starts moving, if we observe in the block, so then studying about that objects under motion is called dynamics. So studying about objects under the effect of force is called mechanics. But after applying force, if the object is under rest, then it is called statics. If the object is under motion, then studying about is called dynamics. Like this, in mechanics, we have two branches. One is statics, another one is dynamics. So next. So this dynamics branch again can be classified into two categories. Again can be classified into two categories. One is kinematics, another one is kinetics. Kinematics, kinetics. So kinematics means it deals with the motion of the objects without bothering about the cause of motion. Means if a body is there, we have applied force. Because of that, what changes we can observe before that? Before applying force, the body may be in position. Because of force, the body's position will change, or the body's speed will change. That speed will change in some time. Because speed is changed, we can tell that it is showing acceleration. Change of speed is called acceleration. Change of speed is called acceleration. Like that, we can observe so many changes. Studying about all these changes, excluding force, without bothering about force, is called kinematics. Means, for create motion in the body, we have to apply force. Once motion started, we will come across so many terms like position, speed, time, distance, displacement, acceleration. Like that, so many terms we will come across. Studying about all the terms which are involved in motion except the force is called kinematics. Except the force is called kinematics. About the reason, it won't study. But because of that reason, what changes are happening, that it will study. In that branch we can study. It is called kinematics. Next, kinetics. Kinetics means it deals with the motion of objects considering the cause of their motion. If we study about the cause also, which is the cause here for motion? Force is the cause. Along with the motion of objects, if we study the cause also, then it is called kinetics. Then it is called kinetics. So here, in this chapter, we will come across a point object. So suppose a block or anything is there. So object means we consider any kind of object as a point object. Point object means suppose I have a block of length 10 centimeter. If it has moved 100 meters, the distance moved by the body is 100 meters. Compared to 100 meters, the length of the object 10 centimeter is very, very, very less. Here 10 centimeter means length of the object. This block will have length, breadth, height, mass, volume, area. Like that, it can have so many quantities. These are all called dimensions of the objects. If the dimensions of the object are negligible as compared to distance traveled by it, as compared to this distance or the measurement with which we are comparing, compared to that, if the dimensions are very, very less or negligible, then this object is considered to be a point object. Point object. In all our problems or all over this chapter, whatever object we mentions about, that will be a point object. That will be a point object. Means whose dimensions like length, breadth, thickness are negligible as compared to distance traveled by it. Okay, children? Next. So here, rest and motion. So what is rest actually? Means we have applied force, but still the object, there is no change in the position of the object with respect to a fixed point around it. So then it will be said to be under rest. Here, a book lying on table. With respect to book, with respect to table, the book is under rest because its position is always same on the table. On one particular position it has been placed, its position is not changing. So compared to table, with respect to table, the book is under rest. Or tree in a garden, compared to this road, or compared to a person who is walking on the road, compared to him, the tree will be in rest position because when he entered into the garden for walking, from that time until he finishes his walking, until that time there is no change in the position of the tree. So that's why we can tell that it is under rest. Means any object or body will be at rest if it does not change its position with respect to fixed point. With respect to fixed point or any object, moving object. The moving object may move, but this tree position will not move. Next, motion. A body is said to be in motion if it changes its position with respect to fixed objects around it, then it will be said to be in motion. So, train moving on a railway track, with respect to person standing on the platform, the train is moving. The train will be moving. Or the children's running in the park, according to this spectators, means other people. According to other people, the children, they are moving. Or according to children, if they hit the ball will be moving. So like that, motion means if it changes its position with respect to fixed objects, so then it is said to be in motion. It is said to be in motion. So here, rest and motion. So rest means said to be at rest, does not change its position with respect to surroundings with the passage of time. Time is changing, but position is not changing. So motion means position changes continuously with respect to surroundings or with respect to observer with the passage of time. So this is about rest and motion. So if we compare this paragraph, we know that Earth is rotating about its axis and revolving around the sun. Revolving around the sun. So the stationary objects like your classroom, tree, lamp post do not change their position with respect to each other. They are at rest. Actually, because your classroom, tree, lamp post, all are situated on the earth. All are situated on the earth. Means one observer, one minute. Suppose this is the earth. So on the earth, we are observing the position of a So we are So we are on the earth. Suppose we are on the earth. So this is our classroom. This is our classroom or somewhat any building. This is our classroom. So one observer is observing the classroom or observing the lamp post, like street light post, lamp post, or he is observing one tree. He is observing one tree which are situated on the earth. A person who is lying on the earth, he is observing his classroom, lamppost, tree. For him, according to this observer, O1, so they are all under rest. They are all under rest. But if we observe from another planet or somewhere else out of the earth, from there, if an observer is observing the position of all these objects, so then earth is not a object which is under rest. It is moving object. Earth is a moving object. Earth is rotating around itself and also revolving around the sun. According to the observer who is outside, for him the tree will be moving, the lamppost will be moving, the classroom will be moving, even this observer O1 also will be moving. So same kind of object, according to observer, first observer, they may be under rest. According to second observer, they may be in motion. Means here the words rest and motion, are not absolute, are not fixed. They are relative. They change from observer to observer. So here, observer to observer. So means observer. So if an observer is situated outside the earth, suppose in spaceship, according to him, classroom, trees, everything will be in motion. So all motions are relative terms. There is nothing absolute. There is nothing fixed. If you move book in your hand, so book is not moving with respect to you. Book is not moving with respect to you. But according to other observer, book will be moving. Okay, according to your hand, it is going along with your hand. According to with respect to hand, it is not moving. But with respect to eyes, the book will be moving. With hand and eye, if the observer is hand, it is not moving because it is along with the hand. If the observer is eye, according to eye, it is moving. Like that also we can take. So here, suppose these two persons, they are traveling in parachute. According to, and the person A, he is on earth. Person BC, they are in parachute. According to this boy, this person A, both of them are moving. But according to person B, person C and is under rest. According to person C, person B under rest. So this rest and motion are relative terms. Means they depend on observer. Based on observer, they may be in rest or they may be in motion. Next. So that's why. So whenever we are observing the things or whenever we are observing the motion, we have to think like a science student. So to the passengers in a moving bus or train, for all the passengers in moving bus or train, trees, buildings, or people on the roadsides, they are observe that the passengers in 1 minute. So the passengers in moving bus, they observe that trees, buildings, people on the roadside, they are all moving. Or outside people, they feel that the inside people, they are moving. Inside people who are in bus or train, they are moving. At the same time, what about each passenger? How do they think? According to them, the fellow passengers are not moving, because the distance between them is not changing. Okay, so the outside people think that all the passengers are moving forward, but the people who are inside the bus, for according to him, the co-passenger is not moving. So okay, so that's why we can tell that motion is relative. Next. So this is one kind of flat car, one kind of flat car. Suppose one observer is outside. So here this is a man's motion. So this is a man and the flat car. This man and flat car, because this flat car is moving forward. Flat car means without having any this top portion. Flat car, it is moving in forward direction. The man is moving in backward direction. The observer who is outside, he will observe the relative motion of these two. Relative motion of these two. Okay. Relative motion of these two. Because these two are moving in opposite direction. So here he is here, because flat car is moving. After some time he might be here. Flat car is moving forward. After some time he might be here. So he will not only observe this this flat car's motion. Along with that, he can also observe the relative motion of this flat car and man. Next. So here one observer is outside the car. Suppose if a pendulum is there, if the pendulum is fixed, so what he will do? He will observe only the motion of the pendulum. Because it is fixed at one place. But here, as the car is moving forward and the person is moving backward, here he will observe relative motion of the man. Next one, about scalars and vectors. So the physical quantities means the quantities which can be measured. Like temperature is a physical quantity, mass is a physical quantity, so volume is a physical quantity, like amount of substance or luminous intensity, all SI quantities, all international system quantities. So all are physical quantities, means the quantities which can be measured are considered as physical quantities. So physical quantities are classified into scalars and vectors. Here scalars means the quantities which are having only magnitude. Magnitude means, suppose if we say 10 meter. So here 10 is a numerical value, meter is a unit. The combination of numerical value and unit is called magnitude. Means scalar quantities, they will have only magnitude. They will have only value, but no direction. Because suppose if you want to measure temperature, or if you want to measure time, for measuring time, how we can tell 10 seconds? This is enough. No need of 10 seconds towards east, 10 seconds towards west. Like that, no need to describe. No need of direction for describing the quantity time. So they will have only magnitude, like distance, speed, mass, time, temperature, density, work, energy, power. These are all the quantities which have only value or magnitude. So, but vector means they will be described with the help of both magnitude and direction. Without direction, they are meaningless. So displacement means we have to tell the direction, because if we suppose if we start from here, we went 3 meters towards east, 3 meters towards east. Next, we went 4 meters towards north. What is our displacement? What will be our displacement from starting point to ending point? This will be our displacement. It means 3, 4. This as it is, this is right angle triangle. This value will be 5. So the displacement is 5 meters towards northeast, because we are going. This is north. This is east. We are going like this at 45 degrees angle between east and north. So that's why our displacement is 5 meters towards northeast. If you won't tell the direction, the person, instead of here, if you tell northwest, the person will be here. If you tell southwest, the person will be here. Southeast, the person will be here. Based on the direction, the person position will change. So that's why for describing quantities like displacement, we need direction compulsorily. Otherwise, we will get wrong assumptions. So displacement, velocity, acceleration, linear momentum, force. About all these quantities we are going to learn, children. These are all quantities are called vectors, because along with magnitude, they need the help of direction for describing them. Next. So vector means any directed line segment is a vector. It will be having 3 characteristics. So one is base, support. Second one is length. Third one is sense. Means support means base, length means magnitude, sense means direction. If it has these 3 quantities, then it is called as a vector. And one more thing, it should follow some geometrical laws. Suppose we went to market, we want to buy sugar, 1 kg sugar. First we have bought 1 kg sugar. Next 2 kg wheat flour. How much weight we are weighing? 1 plus 2 kg, 3 kg. So normal algebraic addition with the help of scalars. These are, mass is a scalar. We can add normally, like normal numbers. But for adding vectors, not algebraic laws. We have to follow some geometric laws. So then if geometric laws are applicable, then only it is called as a vector. Okay, children. So vector means the direction from A to B. So this is a body is moving like this. So the direction from A to B denoted by AB bar. The direction from B to A denoted by BA bar. AB bar, BA bar. So this modulus of AB bar, it's a modulus of vector which gives length of the vector, magnitude of the vector without direction. AB bar means it's a vector with magnitude and direction. Modulus of AB bar means only the magnitude, no direction. If we want to find length of vector or magnitude of vector, we have to make use of modulus. Modulus of a vector. So, if a physical quantity, if it has magnitude and direction, it does not mean that it is a vector. Because for it to be a vector, if this is a vector, or if this is a vector, it should be able to resolve into mutually perpendicular directions, like in 90 degrees like this, 90 degrees like this. Suppose if the vector is y, it should be able to resolve to x, z such that the angle between x, y and z should be 90 degrees. Means x is perpendicular to y. Between y and z, angle should be 90. Z and x, angle should be 90. Z and x angle should be 90. Like that, if they are mutually perpendicular, if the vector is able to resolve into two more perpendicular components, mutually perpendicular components, or we can take in this way. If this is a vector, this is one component, this is one component whose, sorry children, don't consider previous example, consider this example. If this is a vector, so in x direction Vx, in y direction Vy, such that Vx and Vy perpendicular to each other. In this way, if a vector is able to be replaced like perpendicular components, we are removing vector. Instead of vector, we are taking its components, x component and y component, which are mutually perpendicular. So then it will be a vector. Along with having magnitude and direction, it should be resolved into mutually perpendicular directions. That is one condition, and they should follow certain geometric laws of vector addition. So then only it will be a vector. Otherwise, it is not a vector. Okay, children, what we have learned today? So what we have learned today about mechanics means it's study about study of motion about because of force. Two categories: statistics, dynamics. Statistics means only about motion. Motion of objects under rest. Dynamics means objects which are moving, about that it will discuss. Again, dynamics two types: kinematics, kinetics. Kinematics means only studying about motion, not about cause. Kinetics means studying about both cause and motion. Point objects means dimensions are negligible. Dimensions are negligible, very, very small when compared to distance traveled by it. So rest motion. Rest means no change in position. Motion means changes its position. Rest and motion are relative terms. Rest and motion are relative terms. According to one observer, they may be in motion. According to another observer, they may be under rest. So they are called relative terms. They are not absolute. So sometimes the observers may observe relative motion when he is observing one object which is moving on another object. So then he will be able to observe relative motion because of these two. Next, scalars vector means scalar means they will have only magnitude, no direction. Vectors means they will be having both magnitude and direction. Along with that, they should be able to resolve into mutually perpendicular directions. They should follow some geometric laws. Okay, children, thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.